Hi everyone, welcome back. In this video, we are going to understand how X++ actually communicates with SQL Server behind the scenes. Now, many developers write select statements every day in D365FO. We use while select, joins, exist joins, queries, data source methods, and forms that fetch data from the database. But very often, developers don't really think about what happens underneath after writing that X++ code. And understanding this flow is extremely important if you want to build performant and scalable applications. Because at the end of the day, SQL Server does not understand X++. It only understands SQL. So somewhere between your X++ code and the database, translation happens. And that translation directly impacts performance, query execution, index usage, logical reads, and overall application speed. So in this video, we'll understand that entire journey step by step. Let's start with a high-level architecture overview. Suppose a user opens a form in D365FO. For example, customers form, sales orders, purchase orders, or any custom form. When the form opens, the data source executes a query. That query is usually written in X++. Now, the AOS, which is the Application Object Server, takes that X++ query and converts it into an equivalent SQL query. That SQL query is then sent to SQL Server. SQL Server analyzes the query, generates an execution plan, fetches the required data, and sends the results back to the AOS. And finally, the form displays the data to the user. So the actual flow is user to form, to AOS, to SQL Server, to result back to user. And this is very important because every inefficient X++ query eventually becomes an inefficient SQL query. Now, let's look at a very simple example. Here we have a basic X++ select statement. This looks very simple from the X++ side. But internally, the AOS converts this into an SQL query. The X++ select statement is translated into SQL syntax. The where clause becomes an SQL where condition. The table becomes an SQL table reference, and SQL Server now decides the best way to retrieve the data. This is where indexes and execution plans become important. Because SQL Server now has to decide, should it scan the whole table? Should it use an index? How many rows need to be read? And what is the fastest execution path? And those decisions directly affect performance. Similarly, joins in X++ also become SQL joins. For example, if you use join, outer join, or exist join, those are translated into corresponding SQL operations. And later in this course, we'll see how choosing the wrong join type can significantly impact performance. Now let's understand what happens after SQL Server receives the query. Once the query reaches SQL Server, the query optimizer analyzes it. The optimizer checks available indexes, statistics, table sizes, filters, joins, and estimated costs. Based on that analysis, SQL Server creates something called an execution plan. An execution plan is basically SQL Server's strategy for retrieving the data. For example, whether to use an index seek, a table scan, a nested loop, or another operation. And we'll learn execution plans in detail later in this course. So the key takeaway from this video is X++ is not isolated from SQL Server. Every select statement eventually becomes an SQL query, and understanding this relationship is the foundation of performance engineering in D365FO. Once you understand how queries are translated, how SQL executes them, and how indexes affect retrieval, you can start writing significantly better X++ code. In the next video, we'll begin with SQL fundamentals every X++ developer should know before moving deeper into performance optimization. So, I'll see you in the next video.